Okay, so where we left off in class is that we were trying to determine the y-intercepts. And so we know we always substitute 0 in for x when we want to find y. So when I substitute 0 in for x, I get 0 squared over a squared, which of course is 0, and then I have y squared over b squared is equal to 1. I want to solve for y, so I'd multiply both sides by b squared, and then I would have y squared equals b squared, so therefore y would have to be either positive b or negative b. So our y-intercepts on these ellipses are going to be at 0b and at 0, negative b. Okay? Now the segment that joins that shorter distance from top to bottom in this case is called the minor axis. And since 0b is b places from the center at 0, 0, and 0, negative b is b places from the center at 0, 0, then b plus b, or 2b, is the length of that minor axis. Okay? Again, it will always be the shorter. Keep in mind, a is always bigger than b. So if we are no longer on a wide ellipse, but rather move to a tall ellipse, that a squared and b squared are going to flip-flop because the bigger value is going to be used to find the major axis. So when you've got a wide ellipse, your bigger distance, the major axis, is from negative a0 to positive a0. And your minor axis, or the shorter distance, is from 0b to 0, negative b, or 2b. Okay? So if the foci are therefore placed on the y-axis at 0c and 0, negative c, then the a squared and b squared will flip-flop. And therefore, their roles are going to switch. So this next slide is crucial because it summarizes everything we're discussing here about the characteristics of ellipses and their equations. So I would suggest that when you're watching this video, you pause a moment and copy this down. So notice the equations. On the left, we have a wide ellipse. A squared is bigger than b squared, so the a squared belongs under the x squared because it's wider than it is tall. But on the right, we have a tall ellipse. A squared is always bigger than b squared, so the a squared belongs under the y squared instead of the x squared. Okay? A is always bigger than b, and they're always greater than 0. Now on the left, when it's a wide ellipse, the vertices are always on the wider part, or greater length, greater distance on the ellipse. So on a wide ellipse, the vertices are at negative a0 and positive a0. Whereas on the right, for a tall ellipse, the vertices are at 0a and at 0, negative a. Therefore, the major axis is always 2a and the minor axis is always 2b. It's just that sometimes the major axis is horizontal and the minor vertical, or other times the major axis is vertical and the horizontal minor, or the horizontal is the minor axis, excuse me. The foci always sit on the longer axis. So on a wide ellipse, they'll be at negative c0 and positive c0. On the tall ellipse, they'll be at 0c and at 0, negative c. And then the final thing summarized here on this slide is that the relationship between a, b, and c is that c squared is always equal to a squared minus b squared. So pause and jot this down in your notes because it's going to make these examples and then thereafter the problems you're working on your web assignment easier to go about answering. But let's work through this first example. We're asked to find the foci. So what are the coordinates of the two focuses of this ellipse? The equation is a little bit strange. It's not x squared over a squared plus y squared over b squared equals 1. It's something very different. So we need it to be equal to 1. So the first thing we do is to make 144 equal to 1, we divide by 144. Well, everything needs to be divided by 144. So the 16x squared will become 1x squared over 9. The 9y squared will become 1y squared over 16. And then it will equal 1. So all I did to convert that to the simplest form of the equation of an ellipse is I divided everything by 144. Now I notice that the number under the y squared is bigger than the number under the x squared. So a squared has to be 16. This is a tall ellipse. So a squared has to be 16, so a is 4. And b squared has to be 9, so b is the square root of 9. So, again, it's a tall ellipse. So the vertices will be on the vertical axis. So that a will be the y coordinate, 0, 4, and 0, -4. And the b will be the x coordinate of the edges along the minor axis, -3, 0, and +3, 0. But we're trying to find the foci here. So to find the foci, we need to remember that c squared is equal to a squared minus b squared. And if you can find c, then that will tell you about the coordinates, something about the coordinates of your foci. So let's plug in everything we know. We know a squared is 16. We know b squared is 9. So 16 minus 9 is 7. And therefore c has to be the square root of 7. And because this is a tall ellipse, then we know that those foci must be on the vertical axis, on the y-axis. So we'll have one focus at 0, -√7, and the other focus at 0, +√7. Now we can also graph this because now we've got everything we need. We know that we have along the minor axis, we have the edges are -3, 0, and +3, 0 because b was 3. And along the top and bottom, along the major axis, we have the vertices at 0, 5 and at 0, -5. And then we also note that we've now determined that our foci, which always have to sit on the major axis, are at 0, √7 and at 0, -√7. Okay? I can also graph this in my graphing calculator. So let me pause a moment. Well, I was going to try to show you how I graph it on my online graphing calculator, but I'm having issues with my connection. So here's a picture of what you would see. You don't have to enter it in that form. That's only if you're using like a TI-84 graphing calculator, but we're all using the online. So you could have just gone and entered the equation 16x squared plus 9y squared equals 144, and boom, it's going to plot that equation for you or graph that ellipse for you.